Hello everyone, this is Sri Guru over here. Welcome back to my YouTube channel. Today in this video we are going to discuss about the acceleration. In the previous video we have discussed about the velocity. Then also we have drawn a different graphs for a variable velocity, and also we have studied the average velocity, instantaneous velocity, right? Similarly, in this video we are going to discuss about the acceleration. Acceleration means if the object is moving with a variable velocity, that means the object is continuously changing its velocity at every instant of time, that motion is known as accelerating motion. Okay, right? That is the definition I have written here. The rate of change of velocity of an object with time, right? This is the definition. The rate of change of velocity of an object with a time, right? If the object is continuously changing its velocity with a time, that motion is known as acceleration. And the equation is acceleration is equals to change in the velocity divided by time taken for to change that velocity, right? That is okay. And here a is equals to v minus u divided by t dash minus t. What this is representing? Here this v is representing what? Final velocity. V is representing final velocity and u is representing initial velocity, right? And this t dash is what? T dash is representing this is the final velocity, time, velocity at final instant, and t is what? Initial time, right? Initial time. If that we do the equation, then we will get acceleration. Okay, then if this t is equals to 0 and initial time, if we consider the object is moving at a particular initial time is 0 and its final time is t, then if you substitute the values, a is equals to v minus u divided by t. If you rearrange this, then v is equals to u plus at. Correct? What is the SI unit to measure the acceleration? Acceleration is measured in terms of meter per second square and its dimension is L t raised to minus 2. When this acceleration is positive, when this acceleration is negative, it all depends on the value of this v minus u. If the final velocity is greater than the initial velocity and that initial velocity is along the positive x-axis, then a is positive. Okay, if this v is greater and initial velocity is smaller, and if this u is along the positive x-axis, then a is positive. If this v is less than the u and this is u is along the positive x-axis, then a is negative. Okay, when it is positive and when it is negative we have discussed. Then remember all these things. Okay, next is uniform acceleration. Uniform acceleration means here the motion of the object whose acceleration is constant. That means if the object is moving at a particular direction and its velocity is continuously changing, that means velocity is continuously changing with an equal interval of time. That change in the velocity occurs in a equal interval of time, then it is said to be uniform acceleration, right? Similarly, there is another term, non-uniform acceleration. the motion of the object of the body having variable acceleration. That means acceleration is not constant at every instant of time. Right? That change in the velocity is not constant. At a different instant of time, there is a change in the velocity is also different. That kind of motion is called non-uniform acceleration. Okay, note down or take the snapshot of this board. Okay, next term, average velocity, average acceleration. Average acceleration. How we can write the average acceleration? AV, that is total change in the velocity divided by total time taken. It is the ratio of the total time taken by the object to the total time taken. Okay. Total change in the velocity. How we can study this? For this, let us consider a graph x and y, and object is continuously moving with a variable velocity, and that I will represent like this, right? This is the origin. And if you want to calculate the average velocity, that means if the object is moving with a variable velocity, and for that I am drawing the graph here that which gives the curve like this, and I want a average velocity between this motion. Okay, this is the point where along the y-axis we are choosing the velocity, right? At this time the velocity is v2, and at this time the velocity is v1, correct? Along the x-axis we are choosing the time, therefore the velocity at this v1 is t1, and similarly the velocity at this instant of time is t2. Okay, now if you take the slope between these 2 points, that we will get average velocity, then acceleration AV. What he said, there is a change in the velocity. That means this v2 minus v1. v2 minus v1 whole divided by t2 minus t1. Or this is just delta v divided by delta t. This is for a large change in the velocity, then we have to take delta v divided by delta t. Okay, if you want to take the instantaneous acceleration, that means this change in the velocity may be anything, but this change in the time is very small. That means this difference between the t2 and t1 is very small. Then we have to apply for instantaneous acceleration. That means acceleration at that time of instant. Acceleration at that time of instant for this limit of delta t tends to 0. This means that change in the velocity is very, very small divided by delta t, right? Or simply take this as a is equals to dv by dt. This is instantaneous velocity, sorry, instantaneous acceleration, instantaneous acceleration. Okay, note down. Okay, here we are going to discuss about the velocity time graph for accelerated motion. Okay, if the object is moving with having the acceleration, how the graph we will get? Velocity time graph, if you take the slope of that graph, we will get the acceleration. We know this, it is a simple concept. Okay, now see here, the first graph is the object moving with zero acceleration. It means that the object is moving with a constant velocity. Velocity does not change with respect to time. For that, we will get the curve like this. Along the x-axis, we are choosing the time. Okay, and along the y-axis, we are choosing velocity. Correct? If the object is having certain initial velocity, this, okay, however the change in the time takes place, but the velocity does not change, velocity remains the same. That means acceleration is 0. Acceleration is equals to what? Change in the velocity, final velocity minus initial velocity divided by final time divided by minus time. If there is no change in the velocity, if this is a 0 divided by time is anything, right? 0 upon anything is what? 0 only. That means acceleration is 0. Therefore, we will get the straight line. Okay. Now, see here for the second graph. The object moving with constant acceleration. Now, if I draw the graph like this, along the x-axis once again the time only, but here along the y-axis velocity. The object is having the initial velocity is 0. Initial velocity 0, but as the time is go on changing, the object moves straight with a constant acceleration. If you take the slope at any instant of time, you will get the same acceleration. Whether if you take here v2 minus v1, that a is equals to v2 minus v1 divided by t2 minus t1. This is a1, right? Or if you want to take the slope at this point here, if you take v2 and this point as a v1, for a is equals to v2 minus v1 divided by t2 minus t1. This a1 and a2, it remains the same. That means it is moving with a constant acceleration. Correct? Now similarly, now look at the third, the object moving with positive constant acceleration. This is also positive constant only. A1 and A2 are constants. Positive constant acceleration having some initial velocity. That means the object moving here is having the initial velocity 0, but here the object is not having initial velocity 0. That means rather than here, the object is having certain initial velocity, but having the constant acceleration, therefore the graph should be straight line, but it does not crossing the origin. Okay. Now look at the fourth one. Object moving with increasing acceleration. That means there is a change in the acceleration, but that change in the acceleration is constant. Okay. Time. And here velocity. And this is the origin. Okay. Object is moving, positive acceleration. Change in the acceleration is constant at every instant of time. There is an increase in the acceleration. Acceleration is first certain interval of time, it may be a 1 meter per second square. In the second, it is 2 meter per second square. In the third interval, it is 3 meter per second square. At the fourth interval, it is 4 meter per second square. There is a increase in the acceleration, but the change in the acceleration is constant, right? Therefore, we will get the graph like this. Okay? Note down here. This is velocity and time and acceleration. Take the snapshot. Okay, another two graph I'm going to draw here. The first one, the object moving with a constant negative acceleration having a positive initial velocity. The object is moving with a negative acceleration. In the previous graphs we have discussed about the object moving with a positive acceleration, but here the object is moving with a constant negative acceleration. Now see here, along the x-axis once again I am choosing the time, and along the y-axis I am choosing the velocity. Okay, and this is the origin. For this we will get a straight line like this. We will get a straight line. Now see here, the object is having the positive velocity, positive v, right? And acceleration is negative. If you take the slope of this, then you will get acceleration is what? V minus u divided by t dash minus t. Okay, is it right? Now a v is this. Okay, and initial velocity, this is the initial velocity u, this is u, and final velocity is here v, correct? And what is its initial velocity? This one t dash, this one is t dash, and this one is t. Okay, now see here, the sign is get changed here, right? This is a change, therefore a is negative, correct? This is the graph. Now look at the object moving with a uniform negative acceleration having negative initial velocity. Negative initial velocity, that means the curve should be in the next quadrant. This is 0 and this is velocity and this is the time. Okay, from 0 the above line is a positive velocity and the below line is having a negative velocity, but the object is having what? Initially negative velocity only at somewhere at here, right? But acceleration is also a negative, therefore the curve should be like this. Okay, curve, correct? Note down or take the snapshot of this book. Okay, thank you for watching my video. In the next video we are going to solve some numericals on this. Thank you.